Okay, so the idea here is to talk to the community about one of the most important projects we had over the last 6 months that took us a lot of efforts and a lot of resources, but was very, very important for us and very challenging. So just a bit of introduction about my company. So who is Serasoft? Serasoft is a small company, a small Italian company. We provide consultancy around data integration and data warehouse design using open source products. We started our activity in October 2010, and we are located nearby Milan. We have customers in many different sectors, starting from industrial, services, automotive, and insurance. As I think most of you know, I was involved in Pentao project starting from 2005. Then we happily we saw this new initiative with Hope, and so we decided to get on board. And from January 2021, we are deeply involved in the development and the improvements of Apache Hop together with Matt, Bart, Hans, and Nicholas, and other guys. And we think we are the company that has the major competence in Italy at the moment. So we are very happy about that. We currently rolled out Apache Hop with success on 3 customers, and we have 2 more new customers on our list for the next month, we hope. So we are very happy about that. Starting from the next slide, I give a talk to my colleague, that is Leandro Franzoni, that is our business analyst that followed very deeply the project we are talking about. So please, Leandro, you can continue.
Hi everybody, ciao, I'm Leandro and I work with Sergio and I work on this project with him. I work most on the business part and the development of the Hope pipelines and workflows. I will speak about the customer and the contest, and then I will give back the speech to Sergio to go deeper in the technical part. So the customer for of this project is a manufacturing company born in Italy and with plants in Italy and abroad. It is specialized in the production of plastic parts that are strategic for their customers, some of which are patented. It has a short list of customers, but very, very big companies. So it has to be always on time and able to deliver big quantities of products in the time that the customer wants. It is a company that is always searching for process and technology improvements, and we are happy to work with them because we started some years ago with the Pentao data integration, and thank you, Sergio. We started with the PDI-C for some integration, and we had a big step in 2019 because they choose to move towards SAP from the previous ERP system and asked us to implement all the integration from the ERP to the MES and other system that they have in their plants. And last year they asked us to to develop a new part of integration, because they wanted to replace a part of a plant, because they wanted to increase the automation in some areas. And this is the project that we talk now. And this, for us, was and is a special project, because we have to rethink the approach that we used for the other integrations. So please, yes, we can go into the next slide. Okay. So we are in the production area. The customer wanted to improve the automation in the packaging system. Already they have a highly automated production and the system and logistic and plant logistic system that is able to bring to the machines the materials and the accessories that they need to produce, and to bring back to the warehouse the products after the machine did the work. So we have a battery of machines that are producing 24/7 with high speed, and put all the products in boxes. When a box is ready, is completed, the automation system start a robot that goes to the machine, pick up the box, and bring it to the packaging area. This was the new installment that we work on for the integration part. And we need the customer asked us to have a very quick response whenever a box comes in the packaging area, and whenever a pallet is ready to be fulfilled, because the number of boxes for pallet is reached. So due to this time requirement, we had to rethink the way that we used to trigger our procedures, because we always used a scheduled approach, but in this case it was not possible, because we have to react in 1-2 minutes maximum. So we started to think how we can use HOP without scheduling. And we came to the solution that we are presenting now. And I think Sergio is the best guy.
Yeah, so as Leandro said, till now we were used to work with mainly batch those scheduled procedure, but due to the requirements of the customer, we needed to rethink the way we needed to start HOP. And so we decided to move from a scheduled approach to a new approach based on a sort of event-driven architecture to speed up the things the best possible. So let's start looking at how the things works at the plant. So basically we have the industrial automation system that is a very complicated system based on a set of table, and it uses one or more of this table to communicate with the external system. So there exists a very easy table with this is the layout of the real table. So we have 3 columns, very easy. The problem is that at a certain point in time, the automation systems, depending on the request or the things that asks to the external world to be done, writes a record into this table. The real and important part of this record is the XML message contained in the message column, because that message contains the real part of the data that we need to transmit or that we need to update on the target system. So the idea was to think something that as soon as the record was written in the table, something was able to start. Something was able to wake up Hope from sleeping and start the process. With a specific things that this process is not the same every time, the same process, but dynamically at runtime, the system must intercept the message type that is contained in the records. And based on that message type that needs to be extracted from the XML part that we get into the message, we need to open the XML, get the data, and do something, perform some actions in the enterprise system that are influenced by this project. So every time could be a different project. Every time could be a project that is decided at runtime. And we had some constraint, of course, to do this because this process, as Leandro said, must be short-lived. So execution must be the quickest possible. Of course, everything must be transaction aware. So if something fails, everything must be rolled back on each of the systems that we performed some actions. And also the process must be, let me say, persistent, because if for some reason the change detections, can start calling it this way from now, the change detection mechanism stops and needs to be restarted. All the queued records regarding the modification that the industrial automation made from the moment the change detection shuts down to the moment the change detection comes up again, must be also, all the queued records must be processed from the very beginning to the last one. So this was the requirement we had. We made a bit of investigation on the open source market, and we found that there was a middleware that could be fine for us, and that middleware was Debezium. Debezium is a nice piece of software that is made from Red Hat, of course, open source, that is implements the change detection pattern. So it enables application to respond immediately to database changes. It has the characteristic to be a Kafka connector and supports all the major database platform, of course, integrating with the change detections mechanism of the specific database we are going to interact with. There is a, let me say, it's available for all the major platforms. We say SQL Server, Oracle, DB2, MySQL, Postgres, and other minor platforms. So basically, what the Debezium does is to continuously monitor changes in a set of table that we, let me say, we define as source table. It monitors DML and DDL changes, so it's also able to intercept modification to the structure of the table. Of course, in this case, we were not interested in this. And every time it gets a change from the database, that change is pushed on a Kafka topic. And it has the characteristic that if for some reason the Debezium is not available, once it restarts, so basically when Kafka restarts, when the Kafka connector restarts, it restarts from where it left in tracking the changes. So nothing got lost, and that was one of our requirements. So we were very happy about that. And of course, together with Debezium, we also get Kafka in our architecture that I think anyone knows what Kafka is. Kafka, in this case, is a way to track changes made intercepted by Debezium and store these changes in a Kafka topic as JSON messages. We will see an example about that in the next slides. The important detail is that each JSON message produced by Debezium and put into the Kafka topic is stores the detail of the record before and after the change. So we are really able to understand what happened in the record because we have the status of the record before and after. because we are talking about Kafka, of course, to get CDC changes, an application must identify as a subscriber and consume the messages from the Kafka queue. So Kafka for us was interesting because in our looking at the rate of the messages that comes from the industrial automation was the ideal component to relax the rate of messages we received from the field, even if it's a really needed component for Debezium to work. It has the characteristic to be transactional. So if something happened by processing the record we receive from the topic, the records are not lost, but they are resubmitted to the subscriber till the record is processed as fine. And that was a tricky thing to manage for us in Hop. It is also highly scalable. For us, it's good because we expect a growth of the load in the future. So it's really nice to have an architecture that could scale according to our need. And last but not least, of course, Hop is able to immediately react once a Kafka message is published in the queue. So looking at the overall architecture we identified, we thought that using Debezium and Kafka as the enabler for our event-driven architecture was the best choice we can make to have Hop working the way we want. So to have a data orchestration platform event-driven based on Hop, and that was the path we followed. So in this slide we are going to give an overall view of the high-level architecture of the interactions that are made by going through Hop. As we see, Debezium is used to monitor the changes the way we described as an example with the industrial automation and the MES, the manufacturing execution systems. These changes are tracked by Debezium, managed by Kafka. We have a Kafka cluster highly available because, of course, the system must be available, as Leandro said, 24/7, 365. So there are no interruptions. The plants are continuously working. And another important thing is that we also interact with the ERP system, of course, and we also collect some process logs to monitor what happens in the changes, what happened during the process. Some of the implemented process we manage this way are, for example, the work order status lifecycle, as Leandro said, the box fulfillment and pallet fulfillment, process around the master data and BOM integration, material withdrawals, and items quality assurance. These are some samples of projects we manage this way at the customer side. Of course, unfortunately, we can't give a real demo because there is confidential data around this, but we can give a quick overlook at the as a sample of what we call the processor, of one of the processors, so one of the pipelines that react to Kafka, and once the message is published, just to describe the overall flow of the things we do to do our work. Basically, this pipeline is called by what we call a receiver. The receiver is, just show you here, this is the receiver. The receiver is the pipeline that's continuously executing and that contains the Kafka consumer. So as you see, very simple, practically does almost nothing with the exception of managing the errors that can get from the processor. This receiver calls the processor. The processor is the pipeline that looks into the JSON record that comes from Debezium. I just put here for you a sample of a JSON message that we received from Debezium. Of course, not taken from the customer. It's a sample we took from the Debezium documentation. As you see, is a simple, not that simple, but this is simple for just for to be simple. This message, as I described before, has a before and after attributes in it. And as a child of this before and after attribute, we see the record that comes from the database in the previous and current situation, let me say. So this record comes into the injector by means of Kafka. Of course, the first things that we do is to be able to check that for sure we do not process more than one time the same Kafka message we receive. This is just for to be sure that the same Kafka message is not received twice. That sometime never happened in our case, but for to be very sure that everything works correctly, we decided to implement this check. So first thing we do, we check that the offset of the message that we receive is not an offset we received lastly. If the message is okay, we go into the process and we try to understand what happened in the record in the database by which we are receiving the status from the Debezium record. So we get the before part of the JSON message, then the after part, and we took some action to decide in the next 3 or 4 transforms to decide if something is required to be done, because there are some business requirements that are given by the customer and tell us if we need to move on depending on the status we get in the record, or we need to do nothing. Okay, so if something must be done, we move on and we arrive to this point where we look into the XML message we saw before in the record of the table. This XML message, of course, is extracted from the body of the JSON message we receive from Kafka. And looking at the header of the message, we extract the famous message type that is needed by us to decide which pipeline need to be started by what we call the call processor in the next steps. So if everything is fine, next transforms are needed to build the path of the pipeline. If everything is fine, we move on. We call another pipeline that is the real pipeline that made the dirty work. If for some reason in that pipeline something fails, not for let me say, if something happened for functional reasons, okay, not because I don't know, we lose a connection or we weren't able to insert a record, but if for some reason something happened from a functional standpoint in the pipeline, an abort is generated, the processor exits, and the processing returns to the receiver. In the receiver, the process comes out from the error path, of course, and is basically we do nothing with that record, with the exception of writing something in a set of error table we prepare to monitor what happened. But the important thing is that that record is committed in Kafka because it is needed for us that that record comes out from the processing of Kafka. So because if we are unable to commit it let me use this term, remove it from the queue, the process is not able to continue. So we commit it even if it generates an error, but this commit is in Kafka is done to permit the process to move on to the next record in Kafka, to the next Kafka item that need to be processed. Sorry for my English. I hope anyone understood more or less what I described. So we have a a few set of processor because we have a few set of basic process that need to be managed this way. They are more or less, this flow is common to everyone. So it's, let me say, we consider it a sort of generic processing flow for this situation. So just a brief description of the problems we faced during this adventure and how we solved it. First of all, as I said at the very beginning of our presentation, everything runs almost fine, and with the exception of the fact that after a few days of uninterrupted working of the system, we got into a big leaking problem that prevented the pipelines to operate safely without any interruption 24/7 all days. So we worked very hard, but very, very hard, implementing 2 different test systems that continuously runs days and night to monitor, try to understand what happened, try to reduce the set of pipelines that runs until we get into the real troubles. And we was able to, after 3 months of work, we were able to fix everything. Matt was very kind to help me in going deep on this. And now we are very happy because starting from the first days of April, when we put in production the very last modifications and fixes, the Hop listener, so what we yes, we call it the listener. So Hop is operating without any interruption, with a very low. We are very happy to say this. It is using a very low, stable memory footprint. So we're very happy about this. Really happy. That was our major and first problem. Then we have other interesting problem because, as I said, the processor. So this pipeline, excuse me, this pipeline is always running and must never stop. So we had some problem with database connection because in case of temporary unavailabilities of these database connections, once one of the transform that interact with the database tried to do something on the target databases, of course the connection got lost, and we had exception that made everything stopping. There isn't any way to restart the connection because the processor, so this pipeline that is started by the Kafka consumer, is initialized one time for performance reason when the Kafka consumer starts. So database connection are initialized only when everything starts. So to get around of this problem, we decided to encapsulate what we call the database unit of works in a separate pipeline managed by a pipeline executor. You can see some of them here. For example, here when we have the check offset, the get plant data, and the code processor itself, and also this very last call to the pipeline executor for the insert record in error table. These sub-pipeline are needed because they all contains interactions with database, and so they all contains connection that must always run. So in this way, we are sure that when the sub-pipeline is called, every time a connection is initialized, and so we are sure that even if we have connection lost during the processing, every time we are reinitializing the connection, and so we are safe with our problem of of never stopping the running pipeline that is listening from Kafka. Another problem we face that we cannot consider a problem, but just let me say an improvement, is that as we said, the processor, so this steps that is here, that is calling the pipeline that does the dirty work, must run a dynamically must run a pipeline that is defined at runtime, because, as we said, the name of the pipeline depends on the message type we have in the XML message we receive from Kafka. So to try to do the things simpler on this without using subtransformation or things like that, because originally the call processor can handle dynamic pipeline path only by going through variable, we decided to implement a new feature. So to have the pipeline path, complete file name path, by going through a computed field and not only through variables as we have in the original pipeline executor step. This give us the flexibility of reducing, let me say, the complexity of the things, even if we are paying a little bit on the debugging of the things, because the computed fields, of course, is available only at runtime, so the debug is a bit tricky, but we decided that it was not a problem in terms of saving the complexity of the things. I hope in the future to extend this this feature to try to make the things simpler from a debugging standpoint for everyone. And last requirement we had was to, as we already saw when I was describing what we does with the pipeline, it was the error handling, because in case we have a record in Kafka or an item in the Kafka topic that generates erroneous record during its processing, we needed to keep everything always alive and not generate any exception in any place. So to do this, we decided to add a new feature to the Kafka consumer that has the cons that that has the caveats that it works only when the number of record to process is equal to 1, but that was our case. So this is not a problem, and overall it seems to be the only way, for the moment, the only the only way to do this. So we decided to add to the Kafka consumer the error path management. So anytime something goes wrong in the pipeline started by the Kafka consumer, the exception is get, and the Kafka record is put out of the Kafka consumer by going through the error path, is committed in Kafka. So basically is what happens is something similar to the removal of that record from Kafka. And so the process can continue and move on to the next Kafka item that need to be processed. So apart from these things, overall, we decided that it would be nice to have some improvement, to make things easier and cleaner. So we must say that we are proud with the community, because it was very responsive in my request, my stressful request, in fixing some issues and apply some improvement in the GUI. So thank you everybody that helped us to reach this goal. And we also applied to fix a large set of issues during the period from August to January, for ourselves and for anyone else benefit. Because, as I said in the last sentence, this product is made by people for people. So our encouragement for the future is that anyone participate to this project and try to help to make this this system interesting and useful for everybody. So we said everything.
Right. Thanks. Any questions?
Thank you very much, Sergio. That was a great presentation.
Thank you very much. Really appreciate it.
Could you tell us a little bit about the Debezium itself? How easy was it to set up for you on the source database in question? I don't know what.
Excuse me. Um, uh, it's not that hard to be set up. We were lucky because we made a very simple setup. So there is a set of JSON file that need to be set up in the Kafka connector by describing the sources that need to be tracked in terms of tables and schemas. You are free to specify a single table or a set of table by going through regular expressions, so very flexible. Basically, it's a configuration of a Kafka connector that then you need to deploy in the Kafka Connect cluster.
Okay.
I think that there is also a graphical interface made from Debezium, but we are not using it. We are using a tool, a set of tools to monitor the Kafka queue of the Kafka cluster to understand and give the customer the possibility to look into the record and understand if something is, in case something goes wrong, what happened. So very simple for the moment.
Thank you.
We are planning to move everything to Docker, not regarding Kafka, but regarding Hop and in the near future, we hope very soon. So we are already working on this.
I think Debezium has a self-contained Docker image as well for
yes,
people who
yes,
try it.
Debezium has a Docker image that we are using on the test system, and we used extensively to perform our tests for the leaking problem, but they discourage the usage of the Debezium, the Debezium image for production installment. In production, we have a Kafka cluster without any Docker container. So let me say a plain Kafka cluster installation with a Debezium in it. So we have 3 servers production with Kafka on board. Nice project, really challenging, and the customer is thinking to expand the things because they are very happy. They are very happy about this. So we are thinking, and they are thinking to understand if they can use the same approach for other processes they have, because as Leandro said, till now everything is made by going through schedules. So we think that this approach is in certain situation is winning and is cleaner and simple. So we are trying to look with them in which situation we can extend their current processes to work this way.
Okay. There's another question, Sergio, from Stefan Klavke. What was the background why the upstream systems didn't submit information directly to Kafka, so you needed to use Debezium?
Excuse me, can you repeat the question, please?
What was the background why the upstream systems didn't submit the information directly to Kafka? Yeah, so there you have it.
Okay, excuse me. No, the problem is, okay, yes, the need comes from the fact that usually, that was my experience, automation system came from, let me say, from the 80s or from the 90s. So as we say in Italy, when something works, don't touch it because it works. So of course they decided not to touch it, and so they asked us, please solve our problem. Finished. So
Yeah,
of course they didn't. There wasn't any possibility to change the approach and use other things or made any modification to do the things different. They had a table, they write the records in it, and we needed to get some idea to work around this.
Yeah, the customer wants to let every system do the best they are able to do, and use us as they did in the previous project where they implemented the SAP. They wanted us to be the master of the interactions. They didn't want to ask any other provider, any other software house to change the system just to communicate, because they have us that represent the middleware for integration. So they presented us the systems. They told us this system will do these things. This system will need to receive these others. Please choose the best solution for this scenario with the constraints that we tried to explain earlier. So we have the quick response requirement. We have the the peaks management, because we have a lot of machines that are producing and a few islands that are packaging. So the machines are producing in parallel without any coordination. So it could happen that in 1 minute we have 10 boxes to be packaged, and we have 1 or 2 islands. So they wanted to have the process of packaging the quickest possible. So the requirements was the different systems, the very quick response, the peaks, and the 24/7 availability.
So I have one last question, Sergio. Do you have an idea/estimate? So how long does it now take between, let's say, the machine registers the change and it is processed completely? Is it seconds or?
Yeah.
Yes, we are around 30 seconds, 40 more or less.
Okay.
Very quick. I think
Even less, yes.
Yes, I think there is no possibility to reach the same speed in other way.
That high? I expected it to be in below 5 seconds. Where do you lose the time?
Could be because we made a lot of things.
Okay.
Yeah, we have different processes. Some of the processes are very quick,
exactly.
And maybe they require a few seconds. Some of them are bigger because we have to get data from different systems with the, in some cases, with the big query. So I think the point of duration is based on the response of the database.
Yeah.
Okay. Because from Debezium and Kafka, I would expect that you can get sub 1 second latency.
No, but in fact, the response time at that level is very quick. The problem comes after, when we received the record and we must process it. So, as Leandro said, everything depends also on the performance of the system we are going to interact to do our processes.
Yeah, the 40 seconds was from when the record is inserted until when we finish all the actions that we need to do for this for the biggest process, let me say.
No, in fact, we have one process that is really big. I think Matt saw the pipeline just once, but unfortunately we can reduce it because it does a high quantity of things and interact with a lot of systems. Unfortunately, we cannot reduce the complexity of that pipeline, and that is the pipeline that takes that amount of time. So, but it's just one.
Yeah, and
The
you're
response
always
time
limited.
from Kafka is very, very quick. So
The pipeline is always limited to the slowest component. So if you don't need to do something with, I don't know, big query, yeah, then you add a number of seconds, right?
yeah, everything
Yeah.
is depending on the system you are going to interact to. So
Yeah.
But the customer now is very happy with the timing. Maybe in the future when they will increase again productions or they will have some more constraints. We will have to improve also queries, also I don't know, split things. I don't know. We will.
yeah, in next August we will add two more processor for two other kind of processes, and so we will expect a lot of work for us for this, and they will add more power to their production starting from August to December. They are going to triple, I think, the production. So we expect let me say a big growth also in the number of messages received in Kafka. So it's a nice
We will
project.
see. Yeah.
Yeah, it's a nice project. But the important thing is that Hop works and sustains the load. So
Very nice work. Yeah.
What is the amount of changes you get from the Debezium there? So to get a feeling about the load.
in which term?
What amount of records do you get from the Kafka topic?
We are around. There is not a so high frequency, but we are more or less around 1 message per second, more or less.
Okay.
Probably with peaks and then periods of inactivity.
Yes, yeah. We for 5 seconds to 1 second. It depends.
I would have a question. Did the Kafka consumer error buff? If no one else has a question. What exactly is the error case you're addressing here? I do not really get it. What kind of records are caught by that new error buff you added?
For example, if we have a database connection problem in the exact moment that we are trying to read the table, and in some cases we decided to leave the pipeline stop the final pipeline, not the processor pipeline, to be able to put away the Kafka item and go on with the next one. So we could try to handle all the kind of error that we could imagine, but we decided not to go through this path because it could be dangerous, because in some cases we agree with the customer that it was better to skip the item instead of trying to do something strange that could make the things more complex without a real advantage.
Okay, so it's more like a business filtering. So you're filtering out messages you don't like.
Yeah, like yes, yeah.
It's a sort of implicit filter, let me say, because if something happens, we skip it out, and sometimes maybe the record from we receive from the database inside the Debezium message is formally correct, but by going through the processor, by interacting with the other system, maybe, I don't know, a number of order doesn't come out, so we have a null field, and that generates an error. So the error sometimes does not depend on the format of the record we receive from the systems, and that is managed initially by Kafka, but from some computations or actions we take on that field. So
Okay, then I understood that wrong in presentation. I
Yeah,
thought you have some problems that some mail form the records are coming from
exactly,
Debezium, and that,
exactly.
Yeah. Okay, thanks.
Yeah, I guess the lesson is that these scenarios are always messy, right? You assume that the database is always present, but sometimes they buckle under the load. Sometimes the network is iffy, and
Yeah,
it's
there
like
are
the system
lot of
just looks
cases.
for the weakest point if you have something continuously running.
Yeah, we try to identify the identify solutions to have everything up and running, but sometimes there is that little detail that is missing. But let me say that we got into this trouble during the first month, and now, as I said, we are happy with our approach because the system is going without any interruption by 2 months. So sometimes I forget that exists. So you remember, Matt, in the till March. But yesterday I was saying, Leandro, we forget to check if everything works. It is working. So we're happy about this.
Awesome.
Yeah.
Very
Awesome.
nice.
Yeah.
Cool.
That's the way it should be. All right.
Well, any any other questions? Or do we?
Questions about 2.0 maybe? Nothing? Shoot. All right.
Questions about anything you want to see in 2.1?
I'm itching to start working on a new perspective to handle previewing and execution, monitoring, logging, and the whole architecture around that for remote viewing, nested viewing. Yeah. So if you have any ideas, suggestions, throw them somewhere in Jira or whatever.
Okay.
Yeah, start the discussion in the chat. Whatever works for you.
Otherwise, wait until something pops up and then bitch about it. That's fine as well.
Right. And yeah, always, I think this is the 15th time we'll ask this question. If you have any ideas about topics we can talk about in other Hangout sessions, feel free to shoot. We'll probably have one more session before the summer. That'll be announced soon, where Harris Ward will talk about and show a couple of things he built on top of Apache Hop. But we'll need more topics for when we're on the other side of the summer. So shoot those anywhere you like as well.
Hi, hi Sergio, I'm Michele. I have a quick question. Did you slim down Hop at some point, or do you just download whatever was available and you install it?
Excuse me, can you repeat? Can you repeat more
So-
slowly, please?
So the version of Hop that you installed and that is running,
Yes.
just the version that is kind of on the
Okay.
website and downloaded, or did you just remove some of the plugins? So then it was
No. We didn't remove anything. So let me say that we started from a version of Hop that is prior to 1.0, and then we came into with various fixes, improvements, blah 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 blah. We came into 1.0, then 1.1. We are in 1.2, but we didn't remove anything. So the package we deployed is the complete package of Hop. Even if we were thinking to try to understand which are the components we don't need and remove them, but we don't have this hot requirement because we are fine with this. So I think we will move on to .o in the next weeks. So we're preparing the servers for this, installing Java 11, installing Docker because we want to move to Docker, and the next architectural change will be using Docker with 2.0 to perform the things we do now, but with the package as it is, without removing anything.
And
Maybe the question is related to the quick response requirement. But in our case, I think it's not a problem if we start up with a lot of plugins, because we started up at the beginning 2 months ago. So when we receive a new record, we don't have this kind of problem of starting, because we have already the pipeline in execution. So
no,
we did something like this with other processes that we need to schedule very near to each other. But in this case, we don't have this kind of problem.
No, but in fact, as Leandro was saying, this is not the only process we have running at the customer side. We have more or less there are 20 processes based on Hop that are using that are working in a scheduled way, but they are very quick to start, so we don't have any critical requirement. It's not the same as we had in PDI that starts very slowly and required a surgical intervention by me, more or less doing the same thing Matt made on Hope to remove everything that wasn't needed. And we had a version of PDI that starts in a bit. So
I think if you might, it's like something that's kind of cool though. I did find with the Hop thing is that I could download Hop however big the package was. I can't remember what it is to download, but probably 500 megs or something. Is that about right?
Yeah.
And then and I wanted to slim it right down as small as I could. And what was cool is I could throw away all the stuff I wasn't going to use and stuff like that. And I got it down to a package of about like 100 megabytes or something. I mean, the startup time was cool because it's quick and things like that. But the fact that you can throw away the stuff that you don't want and then build this tiny little package. I remember, I mean, Dietard just dropped, unfortunately, but I do remember him doing a Docker tutorial saying, hey, look, you can get Docker with a 64 megabyte version of Java. I'm like, wow, that sounds cool. Then dump a 2 gig version of PDI on top of it. And you're like, really? 2 gigs on top of that, like that? It's just, where's the slim version if you want to be able to distribute it and do other cool things? If you just want to like create a cluster of like, cart servers or something like that, having a 2 gig chunky thing was a bit of a pain. So being able to slim down and cut out all the bits that you don't want from Hop, big data stuff or whatever it is, that's a cool feature to be able to do that. I do like that.
Yeah. The interesting thing is that we can easily tune what we do, what we need for the deployment, and so we can easily tune the startup time by removing very easily the things that we don't need. So that wasn't possible in PDI, of course. So this is a great thing, and gives the possibility to everyone to deploy Hopos on system with low memory footprint and very low resources. And so would like to try to deploy it on the Raspberry very soon. So,
but how cool is that you've been running pipelines for 2 months with a stable memory consumption? That is very a huge thing for the project, I guess, right?
Yeah.
So we now know that there are no major memory leaks, at least not in this scenario. And the more that we see these things, the more we can fix those memory leaks. Yeah, the better for the whole project. Yeah, absolutely.
But my opinion is that we are continuously updating and improving the project. So in my opinion is a sort of debugging. So things that needed to be debugged and find out. Of course, the things that we discovered could be discovered only in a situation like our situation, where we have a process that is continuously running and without stopping anything. Because if we started in a batch way, of course, we started, it does the things and then stops it, so everything is cleaned and In fact, for example, when we had the memory leaking problem, we had this only in the listener of Kafka process, let me say. But the other hop process that were started in the scheduled way were working fine, even if they were working using the same transform I fixed the issue that I fixed without any problem, because when they finished executing, of course, everything was cleared out. So in my opinion, there could be also some minor bits of things that could be fixed, but overall I can say it works. So I can say it works now.
Very nice.
Okay, can I ask another question? It's be more generic. It's not just about hop. Because the process has to be, working 24 hours a day. What if something happen on the server where hop is installed? How do you deal with it?
We hope it doesn't happen. No.
That's not a good way.
No. But the customer has an IT support, and so we tried to explain them how to do some basic thing. But in case something happen, they have our phone number, so they can call us. It's not happened till now. So, but there isn't any other option to fix the things. So.
But I guess the data remains on the Kafka cluster if the hop process goes down. So you have a downtime, but you just have to.
No, in fact, if the hop process goes down, is not a problem overall from the hop standpoint, because when it restarts, everything restarts from where we left. The problem is for the plant, because the plant stops producing. So this is the reason why the customer wakes up during the night if something happens, and not because hop stops. That's not a problem, because hop restarts from where it left.
You could solve it with something like Kubernetes on Docker, where you have the requirement to always have one of the containers running. If it goes down, it restarts on another server, maybe.
No, but in
Something
fact, these are things that we are going deeper for the next architecture we are designing based on Docker. So I was looking on Kubernetes, but I'm not so experienced on this. Maybe I will call you and ask you some help if you can give me some advice.
It should be simple enough to say, okay, we always want to have one instance of the server running but that's like the responsibility then of the clustering aspect of what is called Kubernetes.
Yeah.
But there are other ways to do this, I guess, right? And once you have it running on a Docker container, the next step is easy, very easy.
Oh, in fact,
I just want to have one Docker container with this hop pipeline running on it, and that's if it goes down, it will restart, even if it has to look for another available resource in the cluster. Right?
No, in fact, we absolutely need Docker to solve some other basic issues related to deployment of the pipelines, and because we overall we have more or less 7 servers where we have running processes on PDI and on Hop. So of course we will migrate everything. The plans are to migrate everything to Hop, but to, let me say, I'm trying to get the right term in English, but to make a better deployment, we absolutely want to go to use the containers, so that everything is smoother and cleaner from a development standpoint, because now we have the same set of processes deployed 7 times. So the idea of using the containerization is also to have a deployment process better designed, let me say. So till now we concentrated our efforts on have the things working. Now we try to refine the things and have the things working better. So
really nice.
Yeah, and the 2 questions that popped up in the chat about preview that currently the preview icon in the lower right corner of a transform is currently available in the local run config. That's what Matt mentioned. Well, one of the things that we talked about and Matt mentioned for better preview, better logging, better monitoring. But I guess that will depend on the underlying engine that a pipeline or a pipeline runs on, isn't it?
Well, you basically need something to send that information to.
Yeah.
And the way that used to work was have the hop server send it back to the hop GUI. That's actually a pretty bad architecture. So to solve it in the general case for also for Spark, Flink, Dataflow, the better option is to really engage a logging and monitoring server in the network that is pluggable, that is configurable, so that you can have different kind of backends. And the way that that would work is you have something running in the network, a workflow, wherever it's located, and it would report back when it starts this pipeline or workflow. It would send logging data, performance statistics, even preview data, right? Or in the case if you want to do a unit test, maybe also the complete data set of what a transform gets at a certain point, so that again, remote, not just hop GUI, but a remote um, uh, piece of hop can basically say, okay, what were the execution results of that particular transform. So previewing, unit testing, data profiling results, they are all just different sides of the same dice, right? This like you solve the same problem in once. So logging, previewing, monitoring, um, data lineage, execution lineage, the graphing of these things, it's all the same challenge. If I run something on a remote node on a Spark cluster, I want to know on that node is one node in 100. I want to know what executed that process, where what was responsible, what's going on there, how many records are being processed. I want to see sample rows of things that are being processed. I want to make this less of a black box than it is now. But the same goes if you run something in a hop GUI, a workflow with sub workflow with sub workflow. Right now, you lose the context. You just see the top workflow running. If we have a pluggable system, even without the need to install something in the network, you could have a plugin that says, oh, you always have this local plugin running in hop GUI itself, the minimal version of that, right, the in-memory version. And you would be able to see, okay, I can see now in the sub workflow, in the sub pipeline, I can see everything that goes on. I can use this in the GUI, but you would be able to use it locally exactly as you would do remotely if you set up the plugin system correctly. Maybe through the run pipeline, you can specify then which monitoring and logging service backend you want to use, either in memory locally or again something in the network. Does that make sense? That's sort of like the architecture I'm looking for, so that it becomes much easier to see. I also want to make read-only copies of the metadata if you execute a pipeline. Right now, when it's running, you can still change it, and it becomes tricky to keep track of what was actually executed, especially if it's a long-running thing. In the case of Sergio, for example, if you have something running for months on end, you would probably want to have a monitoring and logging service in the network, a backend that's detached from hop GUI, so that you can see at any given time, I can connect to that logging data, how many records were processed, what is the log, what is going on, and that would be useful, right?
Mm-hmm. Mm-hmm.
All right, so that's sort of like what I had in mind. I sent some mails to dev, but never got really a lot of response from it. So I guess that means that everybody's in agreement that something is needed in that area, and so yeah, it's not bad for a version 1, I think.
There's one more question. Well, thanks for the formula step. Second, what are people doing for SAP access? In PDI, we used the SAP RPC step. Are people using flat file, extracts, SAP, MaxDB, or are there other options? Not my comfort zone, but I know that IT Novum in Germany had commercial SAP plugins that they plan to port to Hop. Not sure what the status is. Yeah, not sure what the status is. I don't think we ported the RPC plugin to Hop. I don't think we can. Not to Apache Hop, at least. We could add it in an external plugins repository if it is portable, if it is any good.
Yeah, it's portable, right?
Well,
Just need to look at the license.
yeah, but if the code needs to be okay as well. I think no, and actually I think the SAP plugin is one of the plugins that were removed in 9.3 or definitely went out of support because, well, what we've seen at the very beginning of Hop is that the yeah, some of the dependencies come from the age of the dodo, and the SAP plugin might be one of those as well. So it's worth looking into. If it is portable, we can port it to an external plugin, but I think it's worth checking the commercial Hop plugins as well.
Yeah, and maybe check with IT Novum. Maybe they can hook you up with a test version or something, or yeah, they're very nice people. So we did a webinar with them this morning, which was very nice. A meetup, an online meetup, I guess.
Yeah.
Also got great questions.
Yeah, they got into, well, Hop unit testing, Neo4j, so some of the good stuff.
All right.
Cool.
Well, thanks for joining, guys. It's been fun.
Well, and we'll announce the next session soon, and that will be the last one before. Yeah, I mean, we're not tired of doing hangout sessions after 2, but we'll need to do a summer break. All right. Thanks, everyone.
Thank you very much.
Thank
Bye-bye,
you.
everyone.
Ciao, ciao.
Ciao, ciao,
Thanks,
ciao,
Sergio,
ciao.
Leandro.
Ciao. You're welcome.
Ciao, ciao.